Hi everyone. Today we are going to discuss about optical fiber experiment. In this experiment, we use it to determine the numerical aperture and acceptance angle of an optical fiber. For this experiment, we need the apparatus like optical fiber kit, numerical aperture jig, scaled screen and 1 meter optical fiber. This is 1 meter length optical fiber cable we are using and connecting wires for this experiment. First, let us see what is an optical fiber. We know already optical fiber is nothing but it is a cylindrical waveguide system which can be operated at optical frequencies. Means optical signals can be transmitted through a fiber over long distances. Nowadays, it is playing an important role in the field of communication to transmit voice, television and digital signals from one place to the other place. Optical fibers works based on the principle of total internal reflection. First, to satisfy the total internal reflection in this optical fibers, it has to satisfy two conditions. First condition is light transmits from the denser medium to rarer medium, and second one is angle of incidence should be greater than the critical angle. Then only light follows the total internal reflection in this optical fiber. In this optical fiber, we are using core is used as denser medium and cladding refers as rarer medium. Here always core refractive index should be greater than the cladding refractive index to launch the light through an optical fiber. And the condition is always when we are incidenting light at an end of the optical fiber, that light should be either in LED or laser. But now here in our experiment in lab, we are using LEDs as internal or incident light sources. Before going to the experiment, let us understand what is an acceptance angle. Here, to understand that one, let us see this figure. In this diagram, this region, it represents core medium, and here core is surrounded by cladding material. Now here, when we launch light at an interface of air medium and core medium, for which the light ray enters into the core and travels along the interface of core and cladding. Here, in this interface region, if the angle of critical angle is less than the angle of incidence, means always to satisfy the total internal reflection, angle of incidence should be greater than the critical angle. Then this light ray, it reflects fully into the core medium and it satisfies the total internal reflection. Suppose here, if this critical angle is greater than the angle of incidence, then some of the light partially it reflects into the core medium and some light enters into the cladding medium. Here, which light rays enters into the cladding medium, that light rays we are assuming as optical fiber losses. So from this known theory, we can say acceptance angle definition is the maximum angle of incidence at the interface of air medium and core medium, for which the light ray enters into the core and travels along the interface of core and cladding. Now let us see what is numerical aperture. Numerical aperture is nothing but light gathering capacity of an optical fiber. Here, when we launch light in 3 dimensions, it forms a cone. In this cone, we know already this is base of the cone. This base diameter we are assuming as W, width of the cone, and this one we are assuming as height of the cone. This height of the cone from this base to the core medium, this height we have to consider as length L. Now by using this width and length. Using this theory, numerical aperture formula theoretically is sine of acceptance angle. Here acceptance angle is nothing but theta max. But here by using this width and height of this cone, experimentally we have another formula, that is numerical aperture is equal to W whole divided by under the root 4L square plus W is diameter of this cone and L is height of this cone. In experimentally, by taking this W and L values, we will get numerical aperture. So now this numerical aperture here, if you observe theoretical formula, we know numerical aperture value and we don't know the value of acceptance angle. By substituting numerical aperture, we have to determine the acceptance angle. So theta max is equal to sine inverse of numerical aperture. By substituting that sine inverse value, we will get acceptance angle in this experiment. Now see the connections for this experiment. This is the circuit diagram. Only we are measuring of numerical aperture and acceptance angle. So only we are using this first kit. Here in this circuit diagram we have voltmeter and milliammeter along with this circuit diagram. Here in this circuit, to launch light we are using red LED, light emitting diode. The reason is monochromaticity. Now M1 is nothing but voltmeter. Voltmeter positive is given to voltmeter positive and negative will be given to voltmeter negative. Then M2 is nothing but milliammeter. Positive is connected to positive of the ammeter and negative will be given to negative. Okay. Connections completed now. Now here by adjusting this power, we are increasing intensity of the incident light, that is nothing but LED intensity. We are adjusting by using this power. Here after these connections in this circuit kit, here we have two cables. For losses we are using two, but here only we are measuring numerical aperture and acceptance angle, so that we have to connect only one end of the optical fiber cable to the circuit. From here light launches into the optical fiber like this. That light, incident light, is passing through the length of this entire length of the optical fiber, and the other end is connected to the scaled screen like this. Here from this end light transmits and from this end light receives the signal. As we discussed in numerical aperture theory, here this circles we are assuming as diameter of the cone in millimeters. If you observe, the first ring value is 10 millimeters and the second ring is 20 millimeters and the next one is 30, 40, 50, like that. We have to take all values in millimeters, and this is the scale here. In this scale, all values are in centimeters, but here values in millimeters. So all values we have to convert into millimeters. So 1 centimeter is equal to 10 millimeters. These values we have to consider as height of the cone, that is nothing but L values, and this diameter values are nothing but cone base values W. So W in millimeters and L in centimeters. So this L also we have to convert into millimeters. By adjusting this diameter values, we have to determine the length height of this cone in L. Now switch off all the lights in room, then you switch on the circuit. Now here by adjusting this power we can change the intensity. Here now I am taking maximum power in the circuit by using this knob. Then see here, this is gathering capacity of this optical fiber. So here light gathered in this entire diameter. Now By adjusting this diameters like this, we have to note down the height of the cone in L. So now I am taking that value at 10 millimeters. So for first ring I am taking that light. So now light is in 10 millimeters like this. See here, now I adjusted that entire output light into the one circle, that is 10. For this one first circle, here we got 1.4 centimeters in scale. 1.4 centimeters nothing but 14 millimeters. Note down that values in the tabular column. Next, again you take second circle, that is 20, like this. So here that light is filled in that two circles. The value is 2.7 centimeters. 2.7 means we have to take 27 millimeters. Like this, we have to take all the circles in this diameter. Now like this, we have to take all values for 5 circles. Note down its numerical aperture values. See here, I took total 5 values, 10, 20, 30, 40 and 50. For 10 we got 14 mm, for 20 we got 27 mm, like that for 30, 51. So we got all L and W values. By using this L and W, we have to determine numerical aperture. These values, these are the numerical aperture values. So now here take average of these 5 values. Finally we got this value 0.293. Here theta max, we know already, theta max is nothing but acceptance angle. NA is equal to, numerical aperture is equal to sine theta max. From that, theta max is equal to sine inverse of numerical aperture. So sine inverse of this 0.336, here I got this value. So like that you have to determine theta max values, and again you take average of that acceptance angle value. This is the value we got here. So for this entire procedure, I got numerical aperture value is 0.293 and acceptance angle is 17.002. This is the overall experiment theory and procedure. Thank you all.